Chapter 1, Lesson 3, Variables and Expressions. Let's get into it. Variables. Variables represent an unknown and are written using a letter. You must memorize all the variables. There's many of them. So what I've done is I've created a little thing so you can memorize all the variables in seconds. Here it is. Start with A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, and Z. That's all the variables, but they're hard to memorize. So I wrote a song to help you. It goes like this. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, and Z. Now you know your variable songs. Next time, won't you sing with me? Now, it sounds very similar to the alphabet song, and the AB teacher stole that from me. It was originally called the variable song. And I think even your elementary school, as far as back as preschool, kindergarten, we're using my variable song to teach English. Crazy. Okay, so notice they're all lowercase. There are uppercase ones, such as capital P. That would be perimeter. Capital A, which is area. And a lot of times when it's capital, it has something to do with a formula. So variables are lowercase. Let's go on to the next part. Variable expressions, what are those? An algebraic sentence that contains a combination of numbers, variables, and operation signs. And here's your 4 operation signs. And let's look at some examples. Translating an algebraic or verbal phrase into a variable algebraic expression takes another good listening ear. Here are some examples. Mathematical phrases in verbal or word. So $3 more than, there's that special set of words, the cost of a sandwich. So in this, we only have a 3 here, and we have the cost of a sandwich, which we don't know. So we use a variable. So what is a good variable to use? Well, we can use S for sandwich, or we can use C for cost. We could use X or R or T or anything we want, really, but it's always nice to have a variable that matches the mathematical phrase. So in this case, I'm going to use C for cost. So over here, you can see I use C, and then it was $3 more than, so I put plus 3. The next one is to less than $6 per hour. So let's search for a good variable here, $6 per hour. It's per hour, so for every hour I make $6. So if I do 2 hours, I make $12, and 3 hours, I make $18, and so on and so forth. So I'm going to use H as my variable. Now it says $6 per hour, so I put 6H, and it says less than, to less than. So I'm going to take away 2 on the back end. $400 rental fee plus $150 per day. So you can see again, it's $400 rental fee plus, get the plus there, $150 per day. So what's my good variable? $150 per day. So D is going to stand for day and not dollars, so don't get confused there. So I'll do 400 right here plus $150 per day, D for day. So what are all of these called? These are called algebraic expressions. All right, this is the meat of the lesson. So this is something you really got to take notes on and make sure you absolutely know. All right, begin. To evaluate an algebraic expression that gives the values of the unknown, you just plug in. Now, a lot of math teachers will use that word plug in, and you're going to hear a lot of math teachers after me, even in high school, say just plug it in. Okay? You plug in the numbers into the corresponding variables. Now, in advanced math in 7th grade, even if I was teaching you regular math 7th grade, I would want you to know all the real terms. So some of you guys are going to go much farther than just a few classes in high school. You're going to be engineers and all types of different things. So let's learn the real stuff here. It's actually called the substitution property of equality. Now think about those words there. Substitution. You're subbing something in. So I'm the teacher in the class, and if I get sick or I'm out of town or something and I need to call a substitute, I can't call, I need to call a substitute someone who is credentialed to be in a classroom with kids teaching math. Okay, I cannot call up like a policeman or a doctor. They are not of equal training to me, okay, for teaching. Just like if a doctor was sick, they wouldn't call me and say, hey, Mr. Coker, come on in. We need you to do brain surgery because our brain surgeon is absent today. That would not be a substitution property of equality. That would be unequal. So right down here it says x is equal to y, and I am telling you it is. So that means they are exactly equal to each other in this moment because it is declared that it is. Then y can be substituted for x in any expression, but only when x is y, only when this is declared. Okay, let's look at some examples here. Example, x is 2. It's been declared. What is x? It's 2. What's 2? It's x. So you can read it either direction. And x plus 5 is equal to 7. Then 2 can be substituted in x plus 5 equals 7 to obtain 2. See how the x is here? And I'm substituting the 2 in for the x, and now it's written with parentheses, and I have a 2 there. It's been substituted. It was declared equal back here. So I can do that. 2 plus 5 is 7. Now let's get into it, some good examples. But before we do, this is in red, and it is the most important thing you can do today. Replace each variable in an algebraic expression with parentheses. Okay, you must do that. It's going to feel a little bit elementary school. It's going to feel a little bit like, man, I can do this stuff in my head, but you've got to do it. There are math problems coming this year that if you don't do this, you're going to get way mixed up. All right, so let's go ahead and start these 3 examples. 1, 2, and 3. Okay, try this. Evaluate each expression if A is 4, B is 8, and C is 12. Those are the given. Okay, those are true. So let's start. 3 times A plus 2 times C. So we write like this, 3 parentheses plus 2 parentheses. A, we need A. What was the substitution property of equality for A? It is 4. 4 is A is 4, so 4 goes here. C is 12. 12 is C, C is 12, so 12 goes here. We just substituted A for 4 because they were equal. Where are they equal? It declares that they are equal. All right, so this is 12, and this is 24, and we get 36. Trying the next one. We have 2 variables together with no operation sign in the middle of them. It means multiplication. So we do parentheses for the A, parentheses for the B, and then we go, what is A? A is 4, B is 8. We have it divided by 16. Then to finish this off, 4 times 8 is 32. And 16 and 32 divided by 16 is 2. And the last one is a good one to have it as an example because it kind of gets crazy. If you only use parentheses, you're going to have parentheses, a parentheses, some parentheses, and another couple parentheses and parentheses. And it's hard to tell which ones belong to each other. So last week we learned about other grouping symbols. We learned about brackets. So we're going to turn this bracket and this parentheses and this into brackets. All right, we'll have the C out here for parentheses for the C. We'll have 5 parentheses for the B and a parentheses for the A. And now we'll use the substitution property. So we'll say C is 12 and B is 8 and A is 4. So then we begin with order of operations. We'll leave the 12 alone. We'll get right into here. This is 40 minus 8. And then we'll do 40 minus 8 is 32. And 12 plus 32 is 44. All right, I got lots of examples here for you guys to make sure you know what you're doing before you start your work. So I will be stopping the video. Actually, a slide will come up for you to answer for these. We're going to work on all the odd ones in this lesson. There, it goes all the way down to 17. So let's go ahead and start this first one, b times a. So we'll do b times a minus a times c. And it gives you all the substitution property of equalities up here for everything. So b is 4, a is 2, so 2 there and 2 here, and c is 3, so it goes there. So make sure that you have everything in the right spot. Put them in the wrong spot, you're going to end up getting the wrong answer. This first side is 8, and this side is 6, and together it's 2. All right, this one down here we'll do again together, 11 times parentheses minus parentheses parentheses. So C was 3, back up here, A is 2, and B is 4. So we start ordered operations, start from left to right. We got multiplication right here, 11 times 3, that comes first. And 2 times 4 is 8. And 33 minus 8 is 25. All right. And this one right here is one of those times where you can change things to a bracket. We go 7, change this parentheses into a bracket, parentheses for the A, plus parentheses for the B, in bracket, minus parentheses for the C. Okay, so A was, can't see it anymore, was 3. Nope. A was 2, B is 4, and C is 3. And then we begin our order of operations. Inside here we have, all right, you try number 7. Okay, so it looks like this, 8, change those to a bracket, parentheses for the A, plus parentheses for the B, in bracket, over, 4, parentheses for the C. A is 2, B is 4, and C is 3. Make sure that you have all the right things in the right spots. I'm going to work to the right. 2 plus 4 is 6. This is 4 times 3 still. And on the top, 8 times 6 is 48. The bottom is 12. And 48 divided by 12 is 4. Try 9. All right, 9, change this parentheses to a bracket, parentheses for the B, plus parentheses for the A, in bracket, over, parentheses for the C, minus 1. B is 4, A is 2, and C is 3. All right, so 4 plus 2 is 6. I'll work to the right again. And on the bottom here is 3 minus 1, which will be 2. And 9 times 6 is 54. And 54 divided by 2 is 27. Try number 11. All right. 28 minus B, C plus A. So we go 28 minus the B and the C parentheses plus the A parentheses. A is 2, B is 4, and C is 3. Starting from left to right, using order operations, multiplication comes first, which is 12. Then we have subtraction here. 28 minus 12 is 16. And 16 plus 2 is 18. All right, we had some examples of these in the notes, so go ahead and try this one. All right, remember we always want to read directions. It says translate each phrase into an algebraic expression. 9 more than 8. More than. Did I say 8? I meant A. So we go A plus 9. Do not have it like this. That's no good. It's more than. Okay, the next one. All right, 3 times P, so it's 3P. Some of you guys might have wrote it like this, but this way is the best way. Us math people like to do things with the least amount of effort as possible. All right, and try 17. All right, it says twice Shelley's score decreased by 18. All right, what was her score? We don't know. So we're going to use S as the variable. We don't know what her score is, but it's twice that. So what's twice mean? It says 2 times the score. We'll put a 2 in front of it, and it says decreased by 18. So we're going to decrease this. So we're going to subtract 18. And there you have it.